All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We are going to pick up sort of where we left off last time. Went ahead and did a couple things offline that I'll quickly cover, but it's mostly stuff we've already kind of seen, so I won't go too much into depth on that. But before we go any further, I do want to just take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Lazaron, followed by our partners, Goboli's Inc. and Matt Oscard. Those are the highest tiers of subscription over on Patreon and YouTube memberships. Followed by our partners, followed by our supporters, rather, who are listed here on the screen. They're a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me cover costs associated with running the channel, things like hosting fees, software licenses, eventually assets, things like that. So thank you for that. It is greatly appreciated and helps me out a lot. With that said, I also appreciate all of you viewers, whether you're joining me here live on the YouTube side or the Twitch side. We do simulcast both. Or if you're just catching this after the fact on the VOD, I appreciate each and every one of you guys. Thank you so much for being here. Without you guys, this project, this channel, none of this stuff would exist. So thank you guys for being here. Soulfoam, it's good to see you. How are you doing? Sakelos, good to see you as well. Hope you guys are doing all right. All right, so I'll quickly just kind of recap where we left off. So we've been working on getting sort of our new asset system integrated into the engine and stripping out the bits of the resource system as we go, or the dependencies on that, and making everything work with the new asset system, which also has the asynchronous asset loading capabilities in it, at least for most asset types. So we've done a majority of that work. The asset system itself, I believe, is complete. We've exercised most of that code, with the exception of the last thing that we have to do is actually scene assets. So last time we actually were working on audio, and that has been completed. We were very close on the last stream, I believe. And there was just a couple things I fixed offline and got that working. And then I also went ahead and did shader assets as well, and got that working offline. So scenes are going to be the last thing that we're going to do. And then at that point, we can actually completely pull out the K resource system as a whole, all of the resource handlers, all that stuff. We're going to delete a bunch of code. And so that's kind of the plan for tonight. And then if we have any time left over after that, we're going to get back to working on the import logic, or our new import pipeline that is external to the engine. So that's kind of the plan for tonight. Hickory, how's it going? Good to see you as well. Good to be seen. Yeah, fair enough, Sakelos. All right, so with that, I also can show you guys this really quickly. We are actually up and running, complete with scenes. I don't think I actually have the audio piped in, so you guys can't hear that, but I'm hearing it over the speakers here, and you can kind of see that triggering on and off. So for some reason, my audio piping into the stream machine isn't working, but it's an issue there. It's not an issue with the executable. So we're kind of back to where we were before, where we can actually set different spawn points and teleport between different zones. I know we don't have a lot of visuals here to represent that, but if we do take a look in the logs, we can actually see a lot of that stuff being done. That's definitely a step in the right direction. And I think probably what I'm going to do is I'm going to go ahead and check in, I think, what I have for now. And then we'll go ahead and get the scene stuff done. So this is kind of the precursor to the other scene work that we're going to have to do. So this is a bit of a temporary thing, because we're going to be treating scenes differently in the near future, but we're not quite there yet. So I'm just going to kind of port over the code to this new system, and then we're going to swap that out when we get to that point. Apotham, good to see you as well. Welcome. Hope you're doing all right. All right, so I did a git status on here earlier, and this is basically all the stuff that we have to check in. So I'm just going to go ahead and get that pushed up. So let's see, we we finished, let's see, I think maybe I might have already committed the audio changes. Yeah, looks like we did. Okay, so reworked the shader system to utilize the new asset system. It looks like we had a couple of other minor bug fixes included. Nothing too major, but just other things that kind of came up along the way. So we'll just go ahead and push that in. Eventually. There we go. Pushed. All right. So, really, the way that I've been handling this, just as sort of a refresher, as a way to figure out exactly what we need to do. And actually, I just noticed that this is actually named wrong for some reason. This has the word terrain in it. It's not supposed to. I wonder if that was like a find and replace issue or something. Maybe a copy pasta. I'm not sure. Did we actually do... Yeah, it's named wrong here too. So let's go ahead and just fix this real quick. Just happened to notice that. All right. Okay. So essentially what we're going to do is we're going to do a search among all the files, and we're going to say resource system request. And this is basically everything that's using the old resource system to request resources and thus assets. So these top two are the actual old resource system itself that we're going to strip out, so we can ignore those. This one is a handler for the shader resource, which we also don't need, so we can ignore that one as well, because that's going to be deleted. So overdrive, that code base actually has a reference to it. I guess I'll go ahead and fix that now. I probably ought to remove that and stick that in a separate code base, but for right now, I'll just fix it. The test bed has got one in there as well for scenes, and that's what this one is as well. And then the zone system also has something in there for scenes. So that is essentially what we have to fix. It's just those three instances of requesting a scene resource. So I think the first one I'm going to fix is actually probably going to wind up being. Let's go ahead and fix zone system first, and then essentially it'll be a copy pasta into the other code bases to go ahead and replace this. Spiro, how's it going? Not first. No, you are not first. You're like 7th, I think, but no worries. Good to have you here. Doing okay. Had some sort of rodent chew wires in my car and it won't start, but aside from that, doing good. How have you been? It's funny. I actually had I had an old car that had the same problem. So it was a 1993 Dodge Dynasty. And if you haven't ever heard of one of those, there's a reason for it, because they only made it for 5 years, and there's a reason for that. But essentially, it sat in a garage for a long time and had rodents get in there and chew the wires, and it did really goofy stuff. Like if I took a right turn and hit the brakes at the same time too hard, the whole car would just die. I eventually figured out I had to pull the dashboard apart, and I eventually figured out that they basically chewed a bunch of the insulation off the wires off. And essentially what would happen is, like, I'd go around a corner and the wires would like move just a little bit and they'd ground out and it would just kill the entire electrical system. So that was fun. I wound up having to rewire that car. So that was, I hope your situation isn't as bad. 'Cause I've been there and done that. Let's see. Nivimi, how's it going? Good to see you. I think I saw that you put something in for in GitHub. I did actually see that. I haven't had a chance to review it yet, though. Do you think that microkernel architecture is good for a game engine, or is it overkill? I don't know that I have an opinion on that, to be completely honest with you. my general opinion on most things in game engines, and that's actually why we're deleting a lot of code here, is because I'm trying to get back to that, is don't go complicated unless you need complicated for some reason, right? Do it as simple as possible first, and then if you need something more robust, make it. But don't start there. Uninvert Z coordinates for skyboxes. Right, I did see that. Okay. Yeah, I have to review it, but yeah, that's something I've been meaning to address, so hopefully it'll just merge right in with all the other changes I've made. I haven't, like I said, I haven't had a chance to look at it, but thank you for putting that in. And if it makes sense and if it fits in, I'll go ahead and merge it. All right, let's see. Abel over on YouTube, how's it going? Good to see you. Galactic Pass is asking, do you use SDF for rendering fonts? Not yet. It's on the to-do list. Probably I'm not going to get to it anytime soon, but at some point we are going to put that in there. I'm probably only going to bother with that for our system fonts that load from a true type font, though. I probably won't bother with that for bitmap fonts. By the way, is scene graph like the standard way when making a game engine framework? It's sort of the old school way of doing it. Scene graphs are not something that's commonly used anymore, at least not as the primary way of organizing your objects. There are other types of graphs that you can use as sort of views of your scene, but like internally, they're generally not represented that way anymore. It's usually, these days, it's more of a view. If you have a scene graph, it's more of a view of the scene versus the way that the scene is actually architected, if that makes sense. Okay, so with this, in fact, I think I can actually get rid of that guy for a second. So with zones, we're always just going to handle this asynchronously, right? Synchronously. I don't really see a reason to load the scene file itself asynchronously. It's basically just a text file. There's nothing really crazy going on with it. I don't think there's really any value to that. That may change if they wind up getting too large or too complicated to parse. But for now, I think we're just going to keep it nice and simple. And so in the asset system itself, we actually have done... we've only done the synchronous version of this. So I'll do kasset scene, and we're going to say scene asset for now. And we're going to do asset system, if I can type, request scene from package sync. Should we do... I think we could just do from... Let's just do scene sync, right? We don't actually need to specify a package here because the package by default is the actual application package. So in this case, that's fine. We do need the asset system state. I don't believe... Yeah, we're just doing an engine systems gets. And we'll do asset state and then the name. And so this is just going to be the zone and the scene name. Now, because of the way that assets work, they require strings instead of names. So we're just going to put this in here and then do a kname string get. We might eventually put in some alternate access points that maybe take k-names instead, but strings were a little bit easier at this level to sort of deal with. So we've kind of gone back to that, at least for now. All right, so that, instead of having to do all this, instead of having to do all of this and do all of this, right, now all we have to do to get a scene asset, right, is just do this. So what we can actually do is we can do a, let's do, I don't know if I can, let me see if I can actually rename this. So say scene asset here. I guess it's not going to let me do it. All right, so scene resource, right? And then we'll delete this one. We'll delete all of this. And then, whoops, deleted the wrong line. No, I didn't. These lines need to go. All right, so we have that. And instead of dealing with a resource now, we're dealing with an asset, right? So we'll just rename this to scene asset, right? So we have fail to request zone scene asset. And incidentally, we are going to be changing this for the game-specific stuff. I just kind of want to get it back to a working condition now. And then when we go to rework the scenes to be game-specific, we'll go ahead and tackle that at that point. All right, so scene create no longer requires a scene resource. It requires a scene asset. So we're going to have to refactor that. And in fact, the entire scene, everything here, instead of using a K resource scene, is going to use a K asset scene. So let me just make sure that we haven't actually forward declared this. We have not. So let's see. We have K asset scene here. And then everything else, I believe, just actually references the scene. So we only really use the asset during creation. Scene C. Right, and that's going to be a K asset scene. Thank you for the follows, by the way. Appreciate that. Haven't seen all the damage, but the error code on my car is telling me that the computer and engine isn't being told to start. Ugh. I say this as a computer guy and a programmer. Computers and cars are annoying. They are super annoying. I much prefer working on classic cars to working on modern cars because computers just make it annoying and expensive. If your carburetor isn't working, you can just pull it apart and mechanically figure out why. But when you start dealing with, ECU issues, it's a heck of a lot more complicated, and I'm just not a fan. But maybe that's just me. Maget's, good to see you. How's it going? I love coding and programming. I hate IoT smart garbage. Yeah, I tend to agree with that too. Yep. Yeah, why does your toaster need to have Bluetooth? Or your fridge, right? I don't get it. When cars have gotten so complex, even programmers hate working on them. Yeah, exactly. It's super annoying. Like give me an old school carbureted engine, right? You have spark, you have fuel, it's going to run as long as the engine rotates, right? Like timing and stuff like that has to be adjusted, but it's not just going to not run. If you have spark and you have fuel, it's going to run. Anyway, /soapbox. Obtuse. I like the username, by the way. First time chatter, welcome. Looking forward to hearing the clickety clacking while I work. Nice. Yeah, I'm using, in case you're wondering, I'm using the Keychron K2 keyboard there. It's got the Gateron Brown switches on it. So pretty happy with this one. I am going to wind up having to change, though, to a split keyboard for ergonomic purposes, though. But emission standards. So, okay. All right. I'm going to go off on a tangent here for a second about emission standards. Right? So you might have noticed in the last 20 years or so that cars have gotten huge. You can't buy a small car anymore, or a small truck, or a small SUV. At least when you compare them to the size of what vehicles were in the 80s and 90s and so forth, right? And the reason for that is because the EPA, at least here in the US, actually has credits that you get if, based on miles per gallon versus the wheelbase of the vehicle, right? So how much space there is between the tires. So manufacturers are literally incentivized to make worse mile per gallon vehicles that are larger because they can get a credit for it than making a smaller, more compact vehicle. It's the most ass backwards thing I've ever seen, and it's super annoying. Yeah, they're not more efficient at all. They just found a workaround. Yeah, exactly. Like they're so much heavier now with all the crap that they put in them that they're not more efficient at all. Can't recall the parrot. It was a parody article, but there was some news about smart toilets that analyzes your poo. I vaguely remember somebody talking about that. Yeah, IoT toilet. Yep. In Canada today, it's illegal to sell fuel cars by 2030. See, and that's ridiculous too. Like I know California is trying to pass that crap too, and it's like you can't take an electric vehicle and drive it across the country in one shot. You just can't. You got to stop and charge it for hours on end. You just can't do that. Like and you're going to tell me like people that have to drive around all day are going to all use electric vehicles? It's just not going to happen. It's just battery technology isn't there. It's more annoying than Google Authenticator. Yeah, I hear you. There are different tax brackets for emissions, which also incentivize larger vehicles, cause emissions limits are more lenient for larger cars. By a lot, too. It's by a lot. As an EV owner, I don't think the infrastructure is quite there yet. No, it's definitely not. That's the problem, right? There's no infrastructure there, and you can't, like, with a petrol vehicle, I can go to a station, fill up in 5 minutes, and I'm back on the road for another couple of hours. That is not the case with an EV. It just isn't. You know, they've gotten faster, sure, but, like, it's not 5 minutes. If you're going to make a cross-country trip, at least here in the U.S., in an EV, you're going to have to stretch that time out quite a lot because you've got to stop and charge. And, not to mention, it's not more environmentally friendly because all the stuff that has to go into making those batteries. And guess what? That power still has to come from somewhere. The power that comes out of the wall that goes into those electric chargers, it's still got to come from somewhere. And it's still coming from fossil fuels. So, yeah, maybe it's not like immediately putting out exhaust, right? But there's other things to it, you know. Keep all the electrics, but let's roll back to horse and carriages, you know. I mean, sometimes. Slight tangent as well, don't mean to get political, but one of the changes in it set tax fine for emissions to 0 for every bracket. Yeah, exactly. It's just super annoying. Like they try to claim it's like this great thing for the environment. It's just not. There's a ratio at play. I live in a sweet spot where around 90% of my electricity is renewable. Let's go Seattle. But the break-even point for my car is around 32k miles for emissions. That's the thing. And the thing is, like a Tesla, for example, you get in an accident with it, you got to throw the whole car away. Right? So, how good is that for the environment? Yeah, yeah. It's not all it's cracked up to be. We catch up on the YouTube side. There are other methods and techniques besides scene graph. Yes, there are. Yep. I would love to watch these, but because I live in Finland, it's pretty late or early, however you want to say it. Fair enough. It's 4 a.m. and I usually don't stay awake too long because then I sleep the whole day. Well, I appreciate you being here. I appreciate you being here nonetheless. There is always the VODs on YouTube as well. Do you see the new physics simulations technique from the University of Utah? I have not, but what I'll do, I will copy that and look it up later and take a look at it. Let's see. Looking to learn graphics programming in between starting with DirectX 11 and Vulkan. Which do you recommend? So that depends on your goal, right? Do you only want to target Windows and or Xbox? If the answer is yes, then DirectX is fine. If the answer is no, then I actually wouldn't recommend either one of those to start. I would actually recommend you start with OpenGL, get familiar with graphics programming, and then jump to Vulkan. So it really depends on where you want to go. W take on old car versus modern car. Yeah. Might have to make an engine tailored to biodiesel if petrol is illegal to sell in the future. Yeah, they keep saying they're gonna make it illegal, but until they come up with a solution that works as well as it, it's just not logistically possible, right? Fellow Finn Baguio. Yeah, he's over on the YouTube side, but yeah. You can repair Teslas. Rich Rebuilds on YouTube is a testament to that. Yes, I've seen it, but they don't make it easy. They like deliberately block you from turbochargers and stuff like not turbochargers. Wait, what do they call it again? What's their I can't remember their term. I keep wanting to say turbocharger, but that's not it. It's not supercharger either. I forget what they call them, the Tesla charging stations, but just got a Ford Flex they can run just about anything. Yeah. That's the way like cars in the 70s were, right? Like you could basically pour Dextane into the fuel tank and it would run. Is it supercharger? Okay. Yeah. Pog charger. Yeah. Like I've heard that like if you get into an accident with it and it gets reported, like Tesla will actually block the supercharger mode from working. I think you can still charge it, but like not at the accelerated rate, even if the accident didn't have anything to do with the battery. They blocked the VIN. That's what it was. Yep. So it's like I don't think I want somebody to have that much control over my vehicle. Forget about all the other ways you can control it from your phone and stuff, which I think is super dumb. Just asking to get hacked, right? Zooked. How's it going? First time chatter. Welcome. Hope you're doing all right. All right. So, was that actually the only change we had to make? Was it literally just a drop-in replacement? I think it might have been. No. Okay. Okay, resourcing. Oh, okay. This is the same. So this is getting rid of base and name. And then we remove K-resource types, and that's it? Really? I expected it to be a little bit more complicated than that. Okay. Let's try it. Testbed main. We're going to have to change all the spots at once. I can't test them individually. I mean, I guess that makes sense, though. Not a big deal. Let's go ahead and just swap them out. I think there was only 3 of them. So let's see. Scene resource. That is up here. So we just do this scene asset instead. We'll remove this. Oops. Remove that. We'll remove this. Take this. Put it. Oops. How did I? Change this to resource. Do that. Rename. And there's one more error in here somewhere. Okay. So, what was the scene name actually? It was this. So we can do that. Actually, we don't even need these 2 steps. We could just use the string. Okay. So that's all that should be required for that. And then I think there's one more. I thought there was one more. Did we get them all already? That doesn't seem right. I thought Overdrive had one. Really? Oh, this would be a problem once we actually delete the scene stuff. So let's actually just do this one more time. We'll call this resource. Delete that. Oops, actually, yeah, we still use test scene. Okay, so that's fine. Delete this. And then, whoops, wait a minute. Track 00 is actually what we need. I thought so. I thought that was different. I'll just leave that there for reference, and then why did that fail? What else is broken in this file? Defines. Maybe it's because that just hasn't built successfully yet. Let me rebuild again. Let's see. Can you show your engine on running? I'm a UI designer and want to see more. So we don't have a lot in terms of UI yet. And if you bear with me here, I'm just rebuilding real quick and I can show you it running. Now, we've been doing a lot of lower level work, so I don't actually have I don't have any game assets in yet. It's all just programmer test stuff, right? So this is what it looks like at the moment, right? We obviously need to get some assets in here. But, you know, we have very, very basic stuff working at the moment. So what we're trying to do actually is we're trying to clean up a lot of the asset logic. I said test because I was looking at the word test on screen. So we're cleaning up a lot of the asset logic and removing a complete system that frankly just didn't really make sense. And so that's what we've been working on, and we're nearing the tail end of that now. So after that, I've got to rework the import pipeline, which shouldn't be too big of a deal. But overall, we've actually simplified things quite a lot. So let's see. If only there was a way to get propulsion going without combustion. Yeah, if only, right? I mean, there are ways, but... Have you implemented some way to tell about memory leaks on memory system shutdown? No, I haven't, but that's because I'm not really worried about it on memory system shutdown. So the way that it works, the way that the whole engine works is we grab a huge block of memory when we initialize, and then we dole everything out from that block of memory. So by the time we shut down, there's actually a lot of steps we can skip releasing stuff, except for stuff on the GPU, because that big block of memory, we just release it back to the OS at the end and we're done, right? So we skip actually a lot of shutdown code. So, I mean, I guess there's a bit of a disadvantage to that, but at some point we are going to be enhancing our memory system to better track leaks, at least per frame leaks. We've got some utilities to kind of do that now, but yeah. Hickory, sure, if you want to do that, that's totally cool. I'm honored. I would be honored. Let's see. P. Gorley, I appreciate the D's emote use there. It's one of my favorites, actually. It's underused. As far as I understand, you preferred a deep development process from the beginning rather than superficially reaching a certain level and then deepening it. Must be fun, but difficult. Yeah, I would say that's pretty accurate, yeah. Because, we kind of wanted to build what we know we're going to need. And that way, hopefully when we get serious into the actual game development cycle, past just this introductory stuff that we're working on, we'll reach a point where we don't have to touch the engine very often. So we've only just started working on the actual game code itself. And as I kind of started piecing things together, I'm like, you know what, this is kind of cumbersome. This system doesn't work. We should simplify this, get rid of this, refactor this. And so we're kind of doing that now. But we've already reduced that by quite a bit. For example, I very rarely have to touch the rendering backend anymore. Like the actual Vulkan code, I don't have to touch that very often at all. And if I do, it's very superficial. So we're already kind of reaching a point where I don't have to mess with a lot of that stuff very often. Thank you for the follow. Appreciate that. You're using the memory arena thing. I still don't get how it works. Yeah, so we essentially have a couple of different allocators at the moment. So, and we're going to have more eventually. But we have one main, what I call a dynamic allocator. It's essentially an arena, right? Where we can pre-allocate a large batch of memory, say 2 gigs in this case, I think is what we have it set to. And then every time we allocate memory with anywhere in the system, let's see, do I have let me find a good example that is tagged. You know what, actually, let me go to K-string, because that has a lot of it. So whoops, keep hitting the wrong key. So we have this k-allocate and we have a k-free, right? And what this k-allocate takes is the size that we want to allocate and then a memory tag. And so these memory tags allow us to split up our allocations per type. We're not currently doing that, but the system is set up in a way where we're going to be doing that at some point. Because some of these things all wind up kind of being the same size, right? And so essentially, we're going to change the way that memory is allocated under the hood based on its tag. We're not doing that now, but we are eventually going to do it. The system was designed with that in mind. So this essentially maintains, this points to our memory system, which maintains an internal free list. So every time we allocate memory, we reach out to that free list rather, and say, hey, give me the first block of memory that is of this size. And we do have an aligned version of this as well, where we can specify alignment. That is right here, right? So if we need aligned memory for like Vulkan or something like that, we have the ability to do that as well. And so what that'll do is it'll just take a bit out of that free list, which also points to that huge block of memory. And then from there, we'll return a void pointer that we can use for whatever we need to use it for. So we have this, and the entire system works off of that. And then within that, we also have something separate called a frame allocator, which is basically under the hood, that's a linear allocator. So what that is it's essentially another block of memory where we essentially, every time we allocate from it, we just move a pointer forward by that many bytes to get the next allocation. And so the benefit there is that allocations have very little overhead, right? The only thing we do is move a pointer. So there's no free list or anything like that to manage. And that is what we use every frame for mid-frame allocations that have to happen within the render loop or something type looped like that. And the advantage there is at the end of that frame, once we've done all the processing for that frame, we just reset that frame allocator. And so that gives us lightning fast allocations within a frame. And so that allocator actually pulls from this allocator under the hood. And so it basically just grabs a huge block of memory, not huge, but a decent sized block of memory that is configurable as well. So we've got a couple of different ways of allocating memory. There's a couple more allocation routines that I want to write. A stack allocator is one, and a pool allocator is another. It's on my to-do list, but we don't have those yet. So that's kind of the high level of it. Garusu, how's it going? Good to see you. Singy, good to see you as well. So much I need to learn. Yeah, I mean, it is a lot, right? But like this stuff, I think this was all done when it was still in tutorial format. So we did go over how all that stuff was written. Thank you for the follow. I appreciate that. Missed the Vulkan code. Can we go back? We don't need a game. All we need is Vulkan. I know, right? Part of me misses writing Vulkan code, but also I'm kind of, in a way, I'm happier that I'm starting to get closer to the higher level systems. Our package system, at least for now, is figured out. Assets are now figured out. So I'm kind of liking the way that this is coming together, and I'm really looking forward to building some game code soon. I think Arena is maybe the easiest allocator to implement. Also, you don't need to implement allocation headers and stuff. Alignment allocations with this are very easy. Yes. Yeah, so the so-called dynamic allocator that I have, has to have a header to tell me how large that allocation is, what its alignment is, and things like that to be retrieved later. Whereas our linear allocator does not have to have all that stuff. So, TLSF for generic allocation is a good option if you don't mind medium large memory metadata, but O of 1 alloc and free. That's fair enough. It's the only generic allocator I use personally. I could look into that, I suppose. The thing I should also mention is this allocation routine here is thread safe as well. So there is that. 2-level segregated fit. I feel like from the name of that, I already kind of know how that works, but I'm going to look it up. I will look into it. Thank you. Let's see. Jeremy over on YouTube asks, first comment, welcome by the way. What's the drive behind this project just because you could? Partially. Was there some edge case for a game you wanted to make that needed an engine that used Vulkan under the hood? So, as part of the intro that I normally give, like when we do raids and stuff, this is the actual sort of central hub for the project. So this was designed to be an educational exercise on a way to build a game engine. It's not the only way. It's not even necessarily always the right way to build a game engine. But it's how to do it from scratch. And the reason that I did this is because I'm looking to sort of recruit or motivate or inspire, if you will, more folks to get into game development, or game engine development, rather. Because I think that more competition leads to more ingenuity, right? We've kind of got the big 3 engines out there, right? And there's some other smaller ones out there. But I think the more of that kind of competition that we have out there, and the more people that we get into writing this kind of stuff, the better off we are. Writing game engines and writing this kind of low-level, semi-low-level systems code is kind of becoming a bit of a lost art. And I think there's so many people now, they're just like, well, let's just use Unity or let's just use Unreal and not think about what's under the hood. And that's all well and good. But, there comes a time when, we're starting to sort of lose those folks that understand how this stuff works under the hood. And I think that that's not a good thing. So I'm hoping to, inspire people to get into that by doing this on my own and saying, hey, obviously this would go much faster with the team, but it's building things from scratch, not just throwing libraries at things, doing a deep dive into how stuff works, trying things, experimenting, see what works, what doesn't work. If it works, why did it work? If it didn't work, why didn't it work? And I think just having this sort of educational resource is something that I kind of wished that I had when I was starting this stuff, and it didn't really exist. So I kind of started doing this. I did it in a tutorial format at first, but of course, any project with this size, it's quickly going to get outgrown. So I think software has become here. Let me pull up something real quick. Here it is. So software development's become a bit like this, right? And this is, I've referenced this for years. Let me just blow this up so you guys maybe can see it a little bit better. But this is basically what your modern software looks like, right? And it always relies on something that was written ages ago by one guy. And when that guy...
Thanks for the streams, man.
Thank you so much for the tier 1 sub, Eyeless. I really appreciate that. Thank you very much for the support. And 6 months at that. Thank you very much. You know, when this guy disappears, what happens, right? You know, so I feel like, you know, this is a very accurate representation of the modern software world. And I think there needs to be more people at this level, right? That can do these kinds of things, because folks at this level are exceedingly rare. Anyway, I'm going to jump off my soapbox about that, but that's why. That's my goal, right? And eventually, obviously, I'm going to use this to make a game. And we're going to take this game all the way to release on Steam and everything. So, you know, it's not just building an engine, but we're actually going to build a game using this engine. So, you know, we're not going to stop at just building the engine. So I hope that makes sense. Reminds me of that Jonathan Blow talk about the collapse of society when crappy software is the standard. Yes, exactly. You know, why does it take Word so long to launch, or Photoshop, or, you know, Blender, for example? Like, why does it take so long for stuff to start up? Why does Chrome take gigs and gigs and gigs of memory, right? You know, node modules is another one for anybody that's done web development. You know what I'm talking about. Anyway. Let's see. CryEngine really popped off this year with Kingdom Come Deliverance 2 release. I haven't looked at CryEngine in forever. I looked at it a long time ago, but like got tired of like my machine just having to essentially go full bore just to run it, right? But that's a number of years ago, so maybe it's improved since then. But sounds like you want to make a bunch of Thanos level game devs. Look at existing engines and be like, I'll do it myself, and then they go build their Infinity Gauntlet of an engine. Yeah, I know. That's what I'm hoping for, right? You know, obviously I would hope that people find this useful as a resource, right? Not the string library, but like the actual system, right? But my hope from this is that somebody goes out there and uses this as an inspiration to build something even more awesome than this, right? Because everybody benefits from that. So, making an organization that's going to make low-level stuff, hardware and software, already doing some things, but I'm solo. Notch mentality, maybe. Yeah, maybe. Let's see. Yeah, why does opening VS take so much memory? Yes. I still have to use it as my debugger because I have to support this cross-platform, and I don't want a different debugging system on every platform. So that's what I use to debug, but I don't code in it. So I hear you there. Hi, I'm new here and also noticed you're writing in C. Well, welcome, by the way. Love C, but it lacks module scoping. What type of naming conventions do you use to circumvent the issue? In a lot of my stuff, I frankly haven't bothered. But what I'm actually switching to with a lot of my newer code, and I'm going to go and retrofit a lot of the older code, is I'm prepending a K onto stuff, right? For Kohi, essentially. That way I don't have like this massive, like, super long names for everything, but hopefully it should avoid collisions. I also only export the symbols that actually need to be exported. I don't export everything. You know, that has a different definition in terms of, you know, for when you're building using MSVC versus Clang or GCC, right? But the idea is the same. I don't export everything, right? Only the things with KAPI on them, for example, are exported. So I also tend to be a little bit careful about what I export so that I don't pollute the global namespace, as it were. But yeah, I've kind of started standardizing on that recently, but this code base is already 4.5 years old, so I wasn't doing that initially. Let's see, tried CryEngine when I was a kid, had a very bad PC, didn't know how to learn stuff, threw away the idea of learning this engine, never tried it since then. Yeah, that sounds familiar, right? I picked up the Torque game engine in 2001 because my computer could actually run it. Because I was written by a bunch of gigachads back in the day. And you could get a license to the engine for $100. So yeah, that was where I started. Namespaces are cool, one of my favorite concepts in software dev. They have their uses, yes. C does not have them though. All right. Let's see, where was I? Oh, so we got all of the scene asset stuff ported over. So let's go rip out some code, shall we? Because I don't think... actually, let me do one more search. Yeah. So the only things left for our resource system are the handlers and the resource system itself that are using that. This is the definition of K resource system request, and then we have one in a resource handler, which is now defunct. So let's go through. I'm just going to open this guy up a little bit and have a quick look here. So essentially, there's a couple things that are going to happen here. All of these resource handlers. So let's see. Can I just... I don't remember if I can do this or not. Nope, I guess I can't. All right. I don't remember how to select multiples in this, so I'm just going to delete them one by one, which is a little bit more satisfying if I'm honest. We're going to delete all these resource handlers in the handlers folder. All that code, gone. The other thing that we are going to do is we have this k-resources sort of type here. So we have this k-resource type. This is going to go. K-resource states. We don't need this anymore either. Whoops. So we're going to delete that. The k-resource structure we don't need anymore. K-resource asset info, we don't need that. We don't need the request info. Okay, so there are a couple things in here that we do need to keep. We do need to keep texture type, texture flag, bits, k-resource shader, this can go. Request info, that can go. K-resource material, we don't need that anymore either. We don't need the request info for that. We don't need the static mesh stuff. We do need these types, right? So these type defs here, we do need those. So we do want to keep that. However, I'm going to get rid of these k-resource name strings. There's defines. We don't need those anymore. So we can get rid of this. We can get rid of this. We can get rid of this. Font glyph, I think we might need to hold on to that. So we're going to clean up some of this stuff as well. We might wind up cleaning up those as well, but I'm going to leave them there for now. Resource bitmap fonts, that can go. System font, that can go. Resource scene, that can go. Height map terrain, that can go. So essentially, this is all we're keeping out of this entire file. Just those things. which is pretty good, I think. And I think a lot of these can actually be moved into a different header file at some point. So we're going to think about that. But for now, I'll leave that there. And then under systems, we have, let's see, the kresource system. So this is going to go, and this is going to go. Okay. Now, I suspect we're probably going to have some includes that are going to poop themselves. So let's go ahead and let's do a complete clean and rebuild. Render a front end. K geometry. That must have been roundabout included a different way then. So that should have been math, which this belongs up here. Terrain.h. Okay. Right, so let's see. I don't think K-asset height map terrain. So that needs asset types. I think though, this is in the runtime, so actually all of these need to be moved around a little bit. So these should all be like that. Texture system. What are we missing here? K-asset image. Yeah, that's asset types. That should be there. Let's see. This is in runtime, so I believe these other things are in core, correct? Yes. Core render types is definitely in there. K-resources. K-resource types, that should be separate. So these... And I do see chats there. I'll just catch up in a second. I just want to knock out most of these things really quickly. Texture system C. We have an unused function. Interesting. Okay. What was that again? That was... I think that was just... Was that just a warning? Must have been. All right, I'm not going to worry about it for now. Material system C. Let's see, K-resource system. Oh, that doesn't exist anymore. And this doesn't exist anymore, nor does this. So this whole thing actually is just a big to-do. We'll have to figure that out later. Not an issue for the present time. Static mesh system. This happens when you rip out a system, right? Okay, static mesh on resource loaded. We don't even have that anymore, right? That's, I think... Yeah, that doesn't even need to be there anymore. Something I forgot to delete, apparently. All right, shader system H. It doesn't know about K handles. Now it does. Let's see. So these are all in core. Yeah. All right. shader system C. Oh, I guess I forgot to actually remove this, which is not being used anymore. So, and I forgot to rename this too. Let's see. Looks like we might have, yep, an include there. Oh, we need to sort out these includes. But before I do that, let me catch up on chat. Actually, I'll do that after the break, just in case there's some folks that might miss that stuff. Okay, so these two need to move down here. This can move down here. Render type utilities. I don't remember where this one is. That's in core, okay. These two need to move down here. Serializers, memory front end, or renderer front end definitely needs to move over there. That's in core, okay, that can stay up there. Okay, so all of these oops. Engine.c. That is going to be, that's an expected one, because we removed the system code, but we didn't actually remove the initialization of it. So that's gone now. 828, that's probably the shutdown for it. Yep. UI plugin. Okay, must have been a roundabout include as well. Standard UI system H. That just needs to know about geometry. Let's see, this again. Input types, is that's in core as well. In fact, actually all of these are going to be external libs. All right, are we done with ads? We are done with ads. Okay. All right, let me see. Catch up on. If you work with a diverse set of libraries or wish to shorten nested ones, it's not too hard to run collisions. Yes. Just a different difference of degrees of problems. Yes, exactly. Yep. It's common with C++ where you see the namespace fs equals std file system. Ooh. Regularly run and use fs for other things. Yeah, see, I would never do that. That would be a no-no, I would think. So you said the project's 4 years old. If you started today, do you think you'd choose a different language like Zig or Rust? The only one, to be honest, that I might have gone with is maybe Odin. Frankly, I don't like the syntax of Zig. Rust, no thank you. I don't like the compiler slapping me every time I try to do something with memory that I know what I'm doing. So yeah, I don't think I would. I don't think I'd use those, but I could see myself using Odin because it's got some nice to haves that might be good. Wild to see someone using NeoVim and a mouse. Thought you were at NeoVim level till you tossed your mouse in wood chipper and went to a tiling window manager. Yeah, so what I do sometimes is I'll use the mouse to sort of highlight things on the screen because it's just a lot quicker. Like when I'm talking about a certain section of code, I'll be like, oh, okay, this right here, and I'll just use that to sort of highlight it. Yeah, it's still kind of a bad habit that I haven't completely gotten rid of yet. Who made the Kohi logo? I actually had hired somebody to make the Kohi logo a couple years ago. So I hired an artist to do that. Yep. Just because the one that I had was kind of crappy, and I didn't feel like coming up with a better one. And I was like, you know what? Maybe I'll let a designer do it. I mean, I have design experience, but logo design is not something I ever particularly cared for. So, I worked with an artist to get it done. Can you see me organized? There's not much to see, but I wanted to show you anyways. I don't know what you mean by that. Would you mind clarifying? Odin mentioned Let's Go. Yeah. I mean, Odin looks pretty cool. I've not actually used it yet, but I've seen people use it. And if I were to go with a different language besides C, it would probably be that. The only other thing that I could see myself doing is I could see myself using the C++ compiler for one, maybe two reasons, and that's it. Constant expression. So I would use that specifically for compile time string hashing. And also operator overloads, but only to be used in the math library. And that would be the only reason that I would switch to the C++ compiler. As far as that goes. Yep. Let's see. Thank you for the sub over on the YouTube side. Let's see. Hi, I'm so young, and the only design pattern I know for low-level code is IIFE, but C doesn't have constructors or destructors. What are your memory practices? Oh, you meant RAII. Okay, all right. So resource, yeah, okay. So obviously, I don't have constructors and destructors. I do, for some things, have like a create and destroy, which is, valid in some cases. Like our texture system has technically acquire, right, and release. And those sort of manage some things under the hood, but there's no one size fits all for everything, right? So I try to avoid object-oriented programming at systems level like this as much as possible. Sometimes there are structs that make sense to pass structs around that have related data and have functions for those things. And yes, sometimes that makes sense. But more often than not, that kind of gets in the way more than it helps. So what I will usually do is something like what I've done here in the texture system is I will actually use, let's go to I guess we can do state pointer. So what I will do is I'll do like a structure of arrays type of thing where, all of the data is stored in arrays like this. So instead of having an array of structures, I'll have a structure of arrays and then access the data via an index, which is just a texture ID to actually get to this data. And it really depends on how the data is actually accessed. The reason I did it for the texture system is because 90% of the time when you're talking about a texture, all you really need is an ID and maybe an internal handle. You don't need all of this stuff being passed around. And every time you pass around these things, you're either having to pass a pointer or you're passing around a copy of a struct with all this crap in it, which you're not going to be using 90% of the time. So, usually when we're talking about a texture, we are either looking for an ID, and that's all we need to know at a specific point, and or the underlying handle that goes to the rendering backend. And so, there's no one size fits all in terms of managing memory. It's kind of different per system. Let's see. Where can I go to clone it? Please let me see it. You mean the game engine? So you can go to, I'll drop a link here. This will take you to, let me open the browser back up. That will take you to this website, which is sort of the core, hub for this entire project. And if you scroll down on this guy a little bit, you'll see a contribute on GitHub, and that'll take you to this page where you can actually take a look at it. Right. So this has a write-up of the project itself, and a couple of, albeit dated, screenshots, and requirements, things like that. However, I should mention, this engine is in heavy development, and it is very, very early, right? We haven't actually released a game on this yet, so I do not consider this production ready in any way, shape, or form. So use it as a resource. If you want to clone it, fine. If you want to fork it, fine. Just as an educational resource. But I would not actually use this yet for any sort of serious project, unless you really know what you're doing. YouTube somehow recommended this stream to me. I'm a C# dev, but I always love watching people code in my language, in any language. Awesome. Well, welcome. I hope you find this useful. We're just kind of jumping around and chatting a little bit tonight, but I am in the process of actually removing a bunch of code. Which, for anybody that's been coding for a while, that sometimes removing code and cleaning things up is super satisfying. So let's see, zone system. We've got, I think, just a dead include. I think I said last time, before we got into the texture discussion. Where was that? Somewhere I wanted to clean up the includes. Now I don't remember where it was. Might have been this guy. Let's see. This one is in... Oh, you know what? This is all game code. These are all going to be... Except for Lumina types. These are all going to be external. So... Let's do... that. Built. All right. Let's run our test project really quickly just to see if we foobarred anything. We just nuked a whole ton of code. So it looks like our sound works. Let me just port to another zone really quickly. Yeah, okay, all that works. Okay, so I guess we should probably commit this. Because this is actually probably another decent sized... Yeah. Look at how much code we deleted, folks. That's kind of awesome, right? So... removed K-resource system and its handlers. Oops. So go ahead and push that to our feature branch. All right. And just to kind of give you guys an idea of what we've accomplished in this refactor real quick. I'm going to compare this to 0.10, which is the current release branch that we're working against. That's probably going to take a second to load. Look how much code we deleted. Error. Yeah, I know, right? Was there an error in the console? Actually, I didn't even look. I didn't see anything, but... I didn't see anything pop up. Or are you just joshing me? No pun intended. Yeah, there was something in there. Not that one. Oh, okay. This is our console. I'm not going to worry about that. All right. I am not going to worry about that one. All right. Let's see. MNAJIMTS is React.js. You could not make a TypeScript engine. It would be crazy. Actually, you say that, but I do actually have. Let me find it real quick. Do I still have it on here? Yeah. On the old YouTube channel, I do actually have a TypeScript engine series. This is the first game engine that I built on here. Now, granted, this is just a 2D engine, and it's 6 years old, right? But I actually did make a WebGL-based TypeScript engine back in the day. Anyway. Oh, noes. Yeah, exactly. Yeah, I leave it there because there actually are still people that watch it and find it useful. So I leave it up there. Arvis unsubscribing. Well, see, Arvis, you're also the reason that I left it up there. Because I knew that you were going to appreciate it. So I left it up there for you, buddy. Because I knew you would appreciate that. And I know Coffee Lava would appreciate that as well. Wow, how did I not even notice the raid? Sorry, I got so caught up in chat, I just noticed the raid. Mudbound Dragon, thank you so much for the raid. Late shout out here. If you guys aren't following Mudbound Dragon, definitely do it. You were working on Pico stuff last I checked, right? Because I was on your stream a little bit earlier today, actually. Welcome, Raiders. I hope you guys are doing well. Sorry for the late introduction, but he snuck in while I was in focus mode. Yeah, that tends to happen sometimes. I try not to do that, but like sometimes my my ADHD kind of works in the opposite way and just like makes me hyper focus. But yeah. So for you guys who are new, I will give you just a very, very quick introduction as to what we're doing here, and we'll go from there. Let's see. Still working on the Pico 8 game. Progress is slow and steady. How's it going here? More red diffs. Yes, lots more red diffs, actually. So we are working on the Kohi game engine, which is a game engine that's built completely from scratch in C using Vulkan as its initial rendering backend. I say initial rendering backend because we do have support for Direct 3D and Metal planned, possibly OpenGL. It is cross-platform, so it is available on Windows, Linux, and Mac OS. It started off as a tutorial series and evolved in formats over the time of the series. And eventually we wound up in a live stream format because it just made more sense for a project of this size. The game engine itself is open source and free. So there is a GitHub link here. And actually the website that we're looking at, I just dropped a link in chat too. So if you scroll down here and you click on contribute on GitHub, it takes you right here. And this is the actual engine itself. So all the code is free and open source. The engine itself will always be free and open source. This is designed as an educational resource, and I think that kind of stuff should be free because I'm hoping to motivate more people to get into this space. So that being said, the engine is Apache 2.0 license, which means you can use it for whatever the heck you want, whether it's personal, commercial, it does not matter. All that I ask is that you say you used it if you used it. Right now, it's very early days in terms of the engine. It is not something that I would consider runtime ready yet, but eventually we will get there. So the other thing that I want to point out is the engine itself will always be free and open source. I don't paywall anything having to do with the engine. I don't do any of that kind of stuff, right? I do have like a Patreon and that kind of thing, but it's optional, right? So the game code itself will not be open source until after I release the game, but the engine that it's built on top of will be. And that is pretty much where we're at. In terms of diffs, I was actually waiting on GitHub to actually catch up because I was actually just discussing that as you guys were coming in. And so we're working on the release 0.10 version right now, and we're on a refactor assets branch. So we've been deleting a lot of code. And let's see, usually it gives me, here it is. So we have 5,600 additions and 15,733 deletions, 773 deletions rather. So we're still at pretty much a 3-to-1 ratio of deleting. But yeah, that's what we're currently working on. Just to put some context on this, we have a refactor assets branch here. We refactored the way that the asset system works to simplify it. We used to have to fill out like a whole series of structs, kind of Vulkan style, to create a request to hand off to our resource system that then took that and handed it off to a separate asset system, which loaded it to disk, handed it back to the resource system, and then the resource system issued a callback to whatever called it. We axed the resource system completely because the initial thought there was to separate the difference between an on-disk asset and the actual resource that would get uploaded to the GPU. But then we wound up having a bunch of systems which were sort of independently managing those resources anyways. So I just removed the middleman and have those systems directly deal with the asset system. The asset system is also now a single line call to load an asset, whether that is synchronous or asynchronous, which is also now supported. We can now load assets asynchronously. And the asset system / VFS has all been Jobified. So we're leveraging our job system that we wrote a long time ago, and that seems to work pretty well. And so we actually just got done nuking a whole bunch of code out of the code base. We completely removed our resource system and all of its handlers, and now we just need to essentially rebuild our asset import pipeline, and that's what we're going to talk about next on the stream tonight. Async C is it truly is JavaScript? Yeah, no. So okay, when I say async, right, like it's really just I guess it's not. It's kind of the right term to use, but also kind of not, right? So what we do, the way that it works is when we request an asset asynchronously, there's a function that we call that we pass some information about the asset that we're requesting, and then we also provide a callback. And that callback is made once the asset finishes loading. So the way that works is that function gets called and then returns immediately a pointer to that asset, even though that asset is not loaded yet. So it reserves space for that asset in memory and returns a pointer to it, even though it's not yet loaded, and you can pull later for updates if you want. And then that is handed off to the virtual file system. That goes ahead and reaches out to the packaging system or loads it off disk asynchronously. When that process completes via the job system, it passes all of the loaded data back to the asset system, and then the asset system goes, okay, this asset is loaded. We had a callback for this. Go ahead and make the callback at that same time. And all of those things happen on a separate thread, so that we're not holding up the calling code. So we can basically load a whole bunch or kick off the loading of a whole bunch of assets at once, and have them return asynchronously. Not until you can do, it's not JavaScript until you can do empty brackets double equals not empty brackets, which ends up true JavaScript, by the way. Yeah, JavaScript has a lot of weirdness to it, for sure. Thankfully, that C does not have. Thank you for the follows over on the YouTube side. Appreciate that. Welcome. Glad to have you guys here. Okay, so we have actually removed our resource system. Let's go to our to-do file real quick, because we actually do need to update this. So we can mark that one as done. We do need to rework the asset import pipeline. to existing Kohi tools instead. And we have actually kind of started this. We just need to kind of continue working on it. And then we also need to rework how hot reloading is going to work. That is going to rely a little bit on this. And then we're going to have to do some systems work to actually support it. So I'm probably just going to implement hot reloading as we need it. Maybe at the shader level, although most of our shaders are actually that's kind of a solved problem, so I might not even put that in right away. I'll probably just add that as we need it. But as a sort of reminder of how the asset system works and how imports work and all that stuff. If we look at the asset manifest for a game, or really for any package, right? So when we talk about packages, any one of these libraries here can technically also have a package with it, right? So the runtime comes with assets under that. It has some fonts that come with it, some images, and some shaders that come with it by default, right? So this is the Kohi runtime package. So it has its own sort of configuration or own asset manifest, right? So actually, if we collapse down some of these other folders, we see here that this has its own asset manifest. So runtime has one. The standard UI library has one, right, where it's got some images and some shaders that come with it. And then, of course, the individual game itself has one. So if we look at Illumina KApp, that also has assets, and this is where all of the game assets exist, right? And it also has a asset manifest of its own. That is the file that we're looking at here. So this, just to sort of review here, obviously this is the package name. This is references to other packages, right? So whenever we load this one, we say we are also relying on kohi.runtime and kohi.plugin.ui.standard. And it gives an on-disk path to where those packages are. So there's two sort of ways that this works, right? So there's the sort of debug functionality where we have these on-disk paths for all of these things. And then there's going to be the release functionality where all of the information that you see in this manifest is actually rolled up along with the assets themselves into a giant binary blob. And we sort of load that thing up, and we'll have a lookup table that looks very similar to this. We'll just basically load the whole thing into memory at once, or maybe we'll wind up paging it if it becomes huge. But that's generally the idea, right? So what we essentially do is we have these references to other packages, and then we have assets themselves. And this is the only other listing in here. So it goes all the way to the bottom of the file. And then each one of these is an asset. So at a minimum, we have a name for the asset. So whenever we are dealing with the asset system, when we request an asset, we don't request it by path, we request it by name. So if we wanted to load itemdb, then we're going to reach out to the asset systems that give me the thing that's called itemdb. That's a binary asset. We also have to know that, but the application will know that. And then this is its path on disk. And so for this, it's just a straight up asset load, and there's nothing too complicated here. There's no sort of source format or anything like that. We also have KMT files, which are materials. And again, we can manually specify those materials. They just have, material properties in KSON format, which is also what this file format is. But if we go down a little bit further, we have this asset, which has another line on it, right? So this is another asset called tree. And its path is to a KSM file, which is a Kohi static mesh. But it also has a source path, which is a OBJ file, right? And so a source path is basically a path that we would use to import a source asset, as we call it, into what we're going to call a primary asset, right? So the primary asset is sort of the format that the runtime knows about and deals with. The runtime knows nothing about OBJ formats. It knows nothing about PNGs or any of that stuff, right? It only knows about the Kohi specific file formats that we've defined. So essentially what happens is, or at least the way that this used to work, is the runtime would say, let's try to load the KSM file, and if that doesn't exist, import this. We're not going to do that anymore because that puts a whole lot of extra logic into the core runtime that doesn't need to be there. That is more a function of what an editor might do or what a debug build of a game might do, but it is not necessarily something that the core runtime needs to know how to handle. So we are actually changing this up to work a little bit differently. And we're going to have the runtime of the game reach out and try to load this file. And if it doesn't exist, we're going to throw an error. And that's going to be it, right? We're going to keep it super simple at that level. And then we're going to have an import process that reads in this entire file and goes through and looks for anything with a source path. And based on the extension of that file, it will run the importer for that file type and import it to the path, right? So we're essentially going to read this file and perform all of the asset imports at once. We're just going to go through the entire list and do that. Initially, we're just going to kind of blind just do the whole thing every single time. And then once we get that core process figured out, what we'll do instead is we'll go in and we'll actually make it a little bit smarter to say, well, only if the timestamp on, two things. Only if this primary asset path does not exist, or if it does exist, but the timestamp of the primary asset is older than the timestamp of the imported asset, then we'll go ahead and run it. And so the flow will essentially be that, right? And this will just be an application, probably a command line application that we run. And we could theoretically trigger that from code as well. The second part of this is going to be the hot reloading. So the hot reloading is basically going to watch this file. So anything that we say, hey, we want to watch this file for hot reloading, we watch this file. And the way that that's going to work is while you have the game running, if you were to run the process, the import process that looks at this file, or specifically you import a particular file directly, then what's going to happen is the import process will run. It will overwrite or create this file, and then, hey, the overwrite on disk of this file will trigger in the other process, in the game process, to say, hey, this file has changed on disk. It needs to be hot reloaded. And so the hot reload, we're going to leave. We'll have the hot reload functionality in the runtime, but we're not going to have the import logic in the runtime. And then what we might also do is we might also set up a service that continuously monitors these source paths. And if those change, then it automatically kicks off an import process, which will import this file. And then if the runtime happens to also be running, it'll pick that change up and auto hot reload the file. So that's, kind of the new process. All right, let me catch up on chat. Spiro, it's only a matter of time. Yes, exactly. Well, I should say that is more likely to happen in C++ than C. I was going to ask about the different threads. You just answered it. The main difference is that JS people don't even understand threading. Yeah, because there isn't real threading in JS, right? So yeah. What did I ignore? Oh, I saw that, but I had asked you to clarify on it, and I don't know that you did. Oh, I see it. Okay. I'm going to open this off stream because I don't want to display it on stream at the moment, but I will review it off stream. I have a tab open with it. Yeah, sometimes I don't see stuff. Sometimes messages scroll by and I don't see it. So feel free to remind me if that happens or bring it up again. But yeah, I did see it. Okay. Looks like you use NeoVim. Do you debug in NeoVim as well with NVim DAP or something else, or do you use a sub debugger? So I did try to use NVim DAP. I did use it for quite a while. In fact, it actually still exists in my config. But I had to walk away from it because debugging, especially multi-threaded debugging, and that just did not work well at all. I had a really hard time with it, just data not showing up. Or incorrect data showing up at times. And it was just really, really hard to use. So what I've been using is this to debug. I don't code in this, but I'll debug in this guy because, nobody wants to really code in VS. So we don't. But it works as a debugger. And the reason I use that one is because it's currently probably the best cross-platform developer out there, or debugger rather. So I can use it on Windows, Linux, and Mac, same configuration essentially, and it just works. So yeah, I hope that answers your question. You'd be so mad if you saw somebody make some obscure hentai game with your engine after this amount of effort. I mean, whatever floats your boat, I guess, right? I mean, if somebody made that, good for them, I guess, I mean, cool, you used it. Awesome. I don't judge. Dane, how's it going over there on the YouTube side? I hope you're doing well. This, yeah. You mean this? Which shall not be named. That's why I censor it. VS. Anyway. All right. So, imports. So, this is essentially the way that this works. So, I'll go ahead and split this, and then tools main, I think was where I was doing this. Did I actually have, or did I have? I don't remember actually now. Let's see, I need the Kohi tools. Or was I writing it in... No, I think it was under here. Yes. Okay. Did I move over all the importers already? I think I did. Yes, I did. Okay, so thankfully we don't have that many importers to worry about, right? So the importers that we have are importers for audio, importers for images, and then we have one for bitmap fonts, one for I guess we don't have one for system fonts because that's not an import. We have one for static meshes from OBJ, and then we also have one for OBJ MTL material files, right? So I split those out. And so we also have some serializers here for those source formats. So generally speaking, the serializers for the assets that we actually use in the runtime are going to be as part of either the core or the runtime. I think they're actually in the core. But the serializers for the source formats belong here. So this Kohi tools is what we're going to use to perform all of these imports. And then here is actually the K-asset importer. And this is actually what is going to do the thing, as it were. So we have import from path, which takes a source path from disk, right? This doesn't deal with packages or any of that kind of stuff, or the VFS or any of that. It deals with straight paths on disk. So we have source path, target path, and then we have the name of the asset and the name of the package that it's going into. And we use those partially. We use these last two for partially for debugging purposes, and I believe pathing might actually play a role. But let me see. I haven't actually looked at this in a bit. Essentially what we do is we strip out the extension from the source path. So this will tell us what we're trying to import, right? So it'll be like an OBJ or a JPEG or PNG, whatever it happens to be, right? So we get the extension, we get the target folder, and we get the target file name from the target path. So we just kind of get those strings. And then we kind of go through here and we say, well, are we importing an OBJ? Yes. And then we kind of go through the logic here. So the way that this works is we use our file system, not our virtual file system, but our file system, which deals directly with assets on or files on disk. So we use that to read the entire text file, and we feed it the source path, right? So we read in the entire source, make sure that that actually loaded correctly, and then we'll do a static mesh obj import. And this will return a number of things. So it'll return a, let's see, it'll return a, so the material file count and the material file paths for one thing, because OBJ files generally specify an MTL file or files. And then also it, let's see, does it actually, am I missing something, or did we not actually have... We're not actually returning the asset anywhere. We should probably fix that. Or actually, maybe we don't need to. No, this writes out the KSM file for us. Okay. I'd forgotten how we were approaching that. Okay, so... So this, I should probably put that in here in comments, right? Parses source file, imports, and writes asset to disk, right? Normally for most imports, that would probably be all you need to do is just this, right? And then indicate success. However, since it can actually have an effect on material files, right? Or it can actually contain material files. Whenever we do one of these, we'll just import the material files as well. I'm not 100% sold on this yet, right? Because the material files themselves, we actually do... Do we actually? We do have some MTLs in here that are in the source path, but not all of them I'm looking at. So, and the reason for that is because these MTL files can contain more than one material. So generally speaking, we loop through however many material files we have, get all of the data that we need out of that, and then go ahead and import the MTL files. Now, we do have a fix me in here, and I'll have to figure this out. We need a different path for the materials to go into. And so, you know, maybe we should try reading this from the asset manifest or something. Because generally speaking, when we're talking about assets in the actual game itself, let me go up here. So you'll have models that'll get, let me expand these actually so you guys can see how this works. So generally speaking, the way that things are organized, and it doesn't have to be organized this way, it's just kind of the way we're doing it, is we have models and then we have source, right, which is where the MTL and OBJs sit. And so we'll import the OBJ, that'll pick up the MTL. And then when we go to export these materials, we actually will need to go outside of the source folder, outside of the models folder, and into materials. But there's nothing that says that it has to be done this way, right? The user could put everything in one file. They could have a different organization system. So we don't necessarily want to be super rigid about that. So we do need a way to specify some additional data specific to this to say, where do we want material files to wind up? So we need a way to actually specify that to the actual importer. And so I'm thinking that we might actually have to change the way that we're detecting what importer to actually use to handle this properly, because we're going to have a lot of situations where we're going to have different requirements for different options when we go to actually import stuff. And we need, a way to pass those different requirements in per import process. Kohi rule 34. Yeah, exactly. Do they have carrot cake in the US? That's an extremely random question, but yes. Yes, we do. Wizard spotted? I don't know about that. Unless you're talking about the mage behind me that's lit up right there. We just don't talk about it. Yeah, exactly. Exactly. Okay. So, what I'm actually thinking is the way that we've kind of done this. Well, all right. Let me walk through the alternate path here for a second, right? So that's OBJ imports, right? If we're just importing an MTL file directly, right, it's almost the same process, except this time all we have to do is read the entire text file, import the MTL to the output file name that we already have, and then we're done, essentially, right? And so what we really need to do is we need to have some way to provide options. And OBJ specifying by the extension is kind of a way that we could do it, right? We could just look at the extension. That's how I was thinking about doing it. But it's not quite robust enough. Like, it might be good if we could do something like, and maybe let's kind of think about this for a second. So if we had a command line utility that we wanted to pass options into, right? Let's say that we were executing this from the command line. Because if we figure that out, then we can figure out how to actually accomplish this in code. So let's take, for example, you know what? I want the quotes, actually. So let's actually paste this. And we'll paste this. We should probably do this first. All right. I guess let me get rid of the comment so we can actually, you know what? I'll leave it here. It's fine. Let me see. This is going to color funny, but it'll be fine. All right. So let's say that we have Kohi.tools, right? And to that, we say maybe -t for target, right? And then -s for source, right? And then we want some other way to pass other options, right? So in this case, we actually may want to pass maybe, MTL target path or something, right? Probably do it this way just to make it a little easier to parse. So we do, MTL target path, and then specify path, and that would be, assets, materials, right? But we obviously wouldn't need this for all types, right? So like maybe if we are dealing with textures, for example. So if we're importing this image asset, we would have Kohi.tools. So the target is going to be this, and then the source path is going to be this, right? And then maybe for this, we would actually need flip y, right? And that would indicate, that we want to flip the texture on the y-axis, yes or no. And we could even say yes or something like that. And so as you can see, by the different types of assets that we're importing, we would need to know what importer to run. And the problem becomes with this too is if we have multiple types of importers for the same type of file. So let's say that we also support, which we are going to be adding at some point, GLTF, right? So let's say that we also want to be able to, import this from a GLTF, but we still need to provide, a target path and maybe some other options, right? We also need a way to tell, based on this, okay, we are importing this, but we also need to use the OBJ importer for this guy and the GLTF importer for this guy. And so there's lots of things to consider here in terms of how we actually set this up. And so I'm thinking that maybe instead of import from path, maybe import from path also takes additional arguments, right? But then we don't actually have all of this logic in here like this, and it doesn't check on OBJ, right? Maybe we do. One thing I've seen in the past is to say, OBJ to KSM, right? And we could do, type equals or something like that, right? And so we could have to specify that maybe, and maybe that's the way that it figures it out. We could technically then, have this be called, obj.old or, some other extension, and the extension at that point doesn't really matter because we've actually specified here, what kind of conversion process we want. And so I tend to think, this is probably the way to go, to be explicit about it this way. And maybe we have an enumeration that we set up internally that tells what kind of what type of conversion we're doing, and then based off of that, it runs the appropriate converter. So, there's lots of different ways we can handle this, because ultimately we want to be able to do it this way, but we also want to be able to look at this and determine how that should be done. So what this is missing is this does not have the context of this, right? So while command line, that would work, right? And it seems like a reasonable option. When we're importing directly from the asset manifest, which is something we want to be able to do, this no longer works, right? So we'd have to figure that out based off of this. And then that would mean that this couldn't work. So we might want to have like a hard, fast rule that maybe it just does look at, while we could be more explicit with it, I think it's going to be easiest in this case for it to just look at the extension and figure that out. And so maybe we also have, let's see, what did I wind up doing? Let me actually comment these for a second. It's not quite as simple as just, doing this on the fly, right? You guys can see how complicated this can get pretty quickly. Let's see. So do we actually use package name for any of this stuff? We have package name here. Oops. So we do use package name for the OBJ import. But why does this need to know about it? Would be my question. Interesting. It does not need to know about it. Package name is actually not used by this. Okay. So that's actually a piece of valuable information. I'll bet, I'd be willing to bet, the other importers don't need to know about it either. So if we get rid of this, and also get rid of that, right? And then we don't need package name here. So that simplifies that. Why can't I type PKG this tonight? All right, so the material obj import also uses it here and here, right? So my thought is, let's see, let's have a look at that. Importer material obj mtl c, and does this use package name? Yes, it does. That's why. Okay. Okay. So I think this probably uses it for every map that we have, if I had to guess. Yes, it does. All right, so the resource name we get directly from the obj file, but objs know nothing about packages, right? However, when we create a material file, and actually if we go into a material file, I mean, there's a couple examples here, right? So the base color here has a map that has a resource name, which we ought to rename that to asset. But the resource name essentially is the asset, and then the package name is testbed in this case, because that's where this actually exists if we look down here. So we do need to actually fill out package name. Or do we, actually? Maybe we don't fill out package name for these imports. No, that's not going to work either. Because if we distribute a package that has materials with it, we would want to specify that. We wouldn't want to roll back to... Okay, so this is actually a really good example, okay? So in our example up here at the top, these two types, so the KSM type would also have to have package name included, right? And that would have to be for this one as well. But, you know, a PNG wouldn't require that, right? To import into a Kohi binary image. That wouldn't require it. But these guys do. So for a Kohi static mesh, this would require it because the underlying material is going to require it. And then, of course, to import a material itself, that's going to require it as well. So that's like another option that we'd have to pass through, right? So this is just another example of how we need this to be flexible because... you know, we have the material or MTL target path that we have to provide. Maybe we do that, right? And then we also have to have the package name, which, you know, would be something like testbed, for example. So we have two options for this type, but we only have one option for this type. And for this type, that one option could be optional, right? If you don't provide flip Y, maybe it does it by, I think we're going to flip Y by default. And so you can just say flip Y equals no if you want to override that. And that's how that one would work, right? So you're going to have, sometimes you're going to have properties that are required. Some properties are going to be optional. Sometimes you're not going to have properties that are required at all. And that's just going to vary based off of all the types that we have. So I tend to actually think that we should probably move we should probably move this logic in here to like a separate function, right? So this and then this, we should probably move to a separate function. Reason being is because we're going to have two ways to get to it. We're going to have this import from path, which I need to add some options here. But then we're also going to have we're going to have access to this from code. So we're going to export some symbols so that we can actually call this in code. So like when we write an editor, for example, we can actually trigger this. Let's see. Just notice you have your own spin on JSON. Yeah, it's very similar to JSON, but we called it KSON. It's very similar, but not exactly the same, right? There are some syntactic differences for sure. For one thing, this supports comments out of the box, but there are some other differences. The reason that we did that is because we needed a format that could store data like this for us. We originally wrote this to support hierarchical. That word always messes me up. Hierarchical data for scenes. So we needed a hierarchy of essentially nodes, right? And I got in the middle of writing that, and I'm like, we could actually use this for a bunch of other stuff. So I kind of generalized it. But I didn't want to have to write full-on JSON parsing because there's a lot of other complexities and things that JSON supports that we frankly just don't need. Plus, it was a good example of how we would write a lexer and a parser from scratch to actually, handle, reading our own custom file format. So it was kind of another exploratory educational thing. Let's see. Have you considered something like import everything in this folder? No, only because that's essentially what the asset manifest gives us, right? So the asset manifest, I'm just going to say, look at the manifest and import everything that's changed. And then watch all the source files and re-import them if and when needed. Import out of a source folder. I mean, the thing is, eventually we're probably going to want that in an editor. But I don't think we need to know about that at this level. At this level, all we should be dealing with is a source path and a target path and some options. Anything that deals with import in this folder, essentially what that would translate to is creating a file list of stuff, right? And so you would generate essentially data that looked a little bit like this based off of all the contents of a folder. And then you would call this using that, right? So I wouldn't do that at this level. At this level, this is just going to be handling individual imports. And then we can wrap this in stuff that could look at a folder or handles drag and drop events or something like that, right? I hope that makes sense. Siva Machina, how's it going? First time chatter, welcome. Why don't you use Rust? I don't want to. Frankly. Is that JS? No, this is what we call KSON, which is Kohi storage object notation, I think, or something. I forget what we said it stood for. It's essentially a take on JSON, but it's it's our own proprietary language. All your assets are ordered. Why not make an index? So when we go to when we actually go to write the binary blobs, those are going to be indexed. They're actually going to be they're going to be indexed, right? So essentially what we're going to store is a hash of the name, and then we're also going to store a offset into the file as to where that actually exists, and how large the actual file is. And then that way we can just throw bits of data around, just bunches of bits of data, very, very quickly, right? So this is only for sort of while you're building the game. And eventually we'll probably have some sort of editor that will be able to add to this file so you don't have to actually add to this. But this file here is used twofold right now. It's used for um, uh, imports to tell where we're going to and from on things, but it's also used um, for the runtime to actually load up our assets by name. So is this an engine to make games? Have you or someone used it yet for anything? So this is a brand new engine that we're building from scratch. It is for games. We have only just scratched the surface of actually starting to write some game code. But since it's brand new, like any brand new thing, it's going to have issues and things we need to work out and figure out. And that's kind of the mode that we're in now. Is we found some stuff as we started writing some game code that was a little bit cumbersome, and we're working around those things now to try and make it a little bit easier to use. And so as we go, at the very beginning, we're going to be probably having to go to the engine a lot and fix things or change things, make them easier to use, fix bugs that we find, things like that. But as time goes on, we're going to be staying more and more into the game code territory. So nobody's really used it for anything as of yet because I'm the only one working on the engine for the most part. There are a couple of folks that have contributed small things here and there, but yeah, not yet. It's too early. Jeet, how's it going? Good to see you. Is there a specific game in mind to be made with this? Yes, there is. So we're going to be making a 3D isometric action RPG. And we've actually already had some discussions around design too. There's going to be lots more of those, but we're actually going to design it mostly on stream. So yeah, the idea is that we're going to put the engine through its paces by making a game with it, and we've already started that process, and we've discovered things that we need to change to actually make that happen. Let's see. That's what I plan to do since it would save me making that manifest. I don't think I need extra options. I get the name and type of data from the file name, and that should be good enough for me. Yeah, so I think for us, the additional options are going to be kind of necessary because I don't know how you would figure that out otherwise. Unless you make assumptions about the file structure, which I'm trying not to do. So that's why we need this. But for like image imports, maybe most images you want to flip on the y-axis, but some of them you don't. So I just want to have like an optional or a list of optional options, if that makes sense. Because I mean, the other thing is I could put it in here, right? I could put that stuff in here, which maybe makes sense too. So like maybe I would say this guy, flip y equals no, false, right? You make a lot of assumptions. All files will be pre-edited to fit. Yeah, see, I'm not making those assumptions. So I can't, yeah, optional options. Yeah, exactly. Well, there's optional and required options. So it's actually both. So, I mean, I could do this, right? And maybe this is the way to go, right? Maybe this translates into this. But what I don't want to have to do is, for this makes sense, right? Because that's going to be an exception case. It's going to be an optional property. But for something like this, I don't want to have to specify every single time that I want to do, this. What did I say? MTL target path is that. I don't want to have to specify that for each and every individual one because that's kind of lame, I feel like. And then also it would have to be like, MTL package name, for example, right? And I don't necessarily want to have to do this every single time. So that's the reason I'm thinking like maybe some stuff I could put in here in the manifest, but I don't really think I'm going to do that. Because the other reason is this manifest gets translated into the binary file listing eventually when we go to make that binary blob. So this is actually used to make that binary package file when we go to release. All right, let's do a left off on this. Need to add required optional options lol to import processes can vary by type importer. All right, let me just catch up with a couple more comments here. Makes sense. Okay, cool. Appreciate debug info. I've been using Sea Lion, but free trial is almost over. Yeah, I've heard that one's pretty good, but I've kind of tried to step away from IDEs because most of them are just too dang heavy for me. I like NeoVim. Just stumbled on your live a minute ago and immediately wanted your dot files. Fair enough. If you want my NeoVim ones, I actually have, if my bot will work. There we go. If you click that link, that will take you to an article that I wrote up about my NeoVim configuration and all of the plugins I use. It's probably about 98% up to date. So you may run into small things that you have to fix, but it'll get you like 98% of the way there. May I ask, in a KMT file, is the setting double-sided already implemented? No, we don't have that implemented yet. We are eventually going to need that, though. But yeah, I don't have it yet. All right, so looking at the time, we are out of time for tonight. I do have to get up in the morning, so I'm going to find somebody to raid. But I wanted to, give a big thanks to you guys for being here tonight and being interactive on both sides. It's been really good. So thank you guys for that. I really appreciate it. I'm hoping to motivate more people to get into the game engine development space because competition is always a good thing. So if you guys would not mind following and or subscribing either on the Twitch or YouTube side respectively, I would greatly appreciate it. If you're so inclined, both would help. The further my reach goes, the more people I feel like I can hopefully convince to sort of get into the more technical side of things. So really appreciate all the follows and whatnot tonight, though. Let me find somebody that I can raid. Let's see. I think I know who I'm gonna go. Oh, I know who I'm gonna raid. He's never actually streaming when I am, but it looks like he's doing game dev stuff. So we are gonna raid Spiro, and it looks like he is working on his game tonight, which is awesome. So he's written a game engine in C, and then he's actually using the browser DOM as his renderer, which is super out of the box type thinking. So we will see what he's up to, and I'll go ahead and drop a link over on the YouTube side as well. Thank you guys so much for being here. I appreciate you guys, and we will see you guys tomorrow night. Have a good one.